Hello and welcome to today's IWCS webinar. My name is Connie and I'll be your WebEx Cisco producer for today's event. Now I am pleased to turn the webinar over to Ed Fenton, your IWCS moderator. Ed, please go ahead.
Thank you, Connie. Our IWCS webinar series event is hosted by the International Cable and Connectivity Symposium. I am Ed Fenton, a cable industry advisor working with the IWCS team. As Connie said, if you have questions, please use the Q&A box on the bottom right of your screen to post a question anonymously. If you wish to contact the presenter or IWCS after the presentation, you will be given the contact points at the end of the webinar. Please note that IWCS does not distribute the presentation slides from either our conference sessions or these webinars. However, please feel free to contact the presenter directly, and they will respond to you individually. Today, we welcome Mabud Choudhury, Standards Manager, OFS in Georgia, United States, who will be presenting his paper on a perspective on the future of MMS. Mabud Choudhury is Standards Manager for OFS. He represents OFS in the IEEE 802.3, Ethernet, and INCITS T11 fiber channel standards. Previously, he was the R&D Manager and Engineering Manager for Product Development, Systems Engineering, and Standards of Copper, Fiber, and Intelligent Cabling Infrastructure Products and Solutions for AT&T Bell Labs, Lucent, Avaya, and CommScope. He has an MS degree in Mechanical Engineering from Massachusetts Institute of Technology and a BS degree in Mechanical Engineering and in Chemistry from Duke University. He holds 32 U.S. patents and has authored several papers, webinars, and IEEE fiber channel TIA standards contributions. Mabud, we welcome you to present at today's IWCS webinar series event.
Hi, Ed. Thank you, and I also wanted to thank IWCS for hosting these webinars and sessions. So as Ed indicated, the title for this webinar and presentation is a perspective on the future of multimode fiber. We actually originally did this presentation at IWCS in Orlando in 2017, October 2017, and then one of the co-authors, Yi-Sun, actually presented this at the IWCS UL forum in Shanghai in March. So this is sort of an updated view from March. And before I dive in, any webinar or presentation that has the word future often cites the quote that I'm sure many of you have heard, that predicting the future is tough. Making predictions is tough, especially about the future. So we try to keep things updated. We try to keep things current as we move forward. Make sure I got things going here. All right, we'll go in the right direction. So for the agenda today, I'll cover some overview of the presentation. There's some background, some history about VCSELs and multimode fiber, standards roadmaps, how they fit into the view of the future of multimode, some key markets and future trends, the standards ecosystem and updates on standards, a focus on OM5, which is a relatively new version of laser-optimized multimode fiber, and then next-generation multimode PHYs and PMDs that are being developed. And I promise I'll try and cover these acronyms as I try and go through them. So the initial overview, LOMMF, our first acronym, is laser-optimized multimode fiber, and VCSELs, vertical cavity surface emitting lasers, really have been the link choice for short reaches. So that's anything less than 100 meters or even anything less than 300 meters for a significant period of time, certainly up through 10 gigabit type data rates. I think what we'll show in this webinar and presentation is that our perspective and view is that multimode and VCSELs will continue to retain a strong market position. It won't be as dominant as in the past. There's a lot of single mode solutions out there, but we really do believe that there's a strong market position for these links, both in Ethernet as server and switching speeds increase, and also another key market for these links in the enterprise space is fiber channel storage networks. That's 90% of fiber channel today are multimode VCSEL links, and we see that staying pretty steady going forward. We'll also talk about, I'll present some of the different changes that are happening in the market. Obviously, changes with regard to cloud, with hyperscale, with hybrid clouds, IoT. So there's a lot of trends, and how that impacts multimode and VCSELs will be covered. The second part of the overview is essentially the standards ecosystem. So from an application perspective, IEEE and INSIT's T11, which creates fiber channel standards, OIF, really help drive what happens, and then there's a virtuous cycle here with ISO, IEC, and TIA that generate cabling and component standards, and really provides the foundation on where multimode and VCSEL solutions add value to the industry and the end customer. To supplement that, there's also MSAs, which are multi-source agreements, along with multi-vendor proprietary solutions that also provide application solutions. OM5, as I indicated, is something that over the last few years, the industry fairly rapidly standardized. It's become commercialized at this point. And the last topic that I'll cover is the IEEE. And what's in this presentation is the study group version of that, which was next generation 200 and 400 gig PHYs over fewer multimode fibers. That's since moved on and updated, and I'll verbally provide some of those updates. So in terms of background and history, multimode fiber and VCSELs were developed in the late 1980s. There's over 1 billion VCSELs that have been sold, just sort of one, and in terms of multimode fiber, almost 13 million kilometers over the last 10 years, so that's 33 trips to the moon if you lined up all that fiber. The key takeaway here is that VCSELs and multimode fiber for a sustained period have been high volume, reliable, interoperable, and commercially successful solutions. One of the issues that all technologies face, it's not just in fiber optics, is the issue of scale up, essentially. So you can have a brilliant idea in a lab or a university, you can have a startup, you can have an OFC demo, but what really works is when you've scaled up to volumes in the millions and can service the industry, and VCSELs have that established foundation in place. Also, as background, in terms of key advantages, and this is some material that Finisar provides on their website, and Finisar is one of the companies that makes a range of optical modules and solutions and transceivers. So it's multimode, single mode, the whole range of products. For VCSELs, they're low cost, their manufacturability, integration, reliability, testability, scalability, packaging, custom packaging, and low power relative to LEDs, light emitting diodes, and edge emitting lasers, ELs, and also DFBs, which are not covered here directly, distributed fiber lasers. So the advantage in multimode fiber is that it's a larger core size than single mode, and therefore the alignment costs are lower. It leads to lower cost, and it also has a higher resilience to contamination. So from a usability perspective, it has some advantages on the connectivity side in particular relative to single mode. Also, as background, we're really looking at some market forecasts. This is a 2017 CRU forecast for multimode fiber in the different grades that's shown. It's a small chart. And as I'll present in the IWCS that's coming up in Providence, Rhode Island, we have more updated CRU projections, presented with their permission. There's another chart here in terms of how VCSELs are projected. Light Counting is a source here, which is an excellent market research company that projects the growth of VCSELs. There's some red bars there that show an explosive growth in VCSELs, and they're really, I guess one way to put it, are the cousins of multimode VCSELs. They're single-moded VCSELs that are used for sensing Face ID, Apple's VCSELs. So while they're not directly related to communications VCSELs, there's a lot of overlapping technology and economies of scale where VCSELs stay relevant in the market. In terms of wideband multimode fiber, so WB-MMF, which uses short wave division multiplexing, SWDM, and is now called OM5. OFS made a presentation in 2015 at IWCS in Atlanta, and in terms of hoping that our predictions actually become reality, OM5 is now a standardized and commercialized product. The next slide I have here is from the Ethernet multimode roadmap. This is Ethernet Alliance, which provides essentially the work and activity that's happening in IEEE's 802.3 working group organization. And when this presentation was put together, in terms of future multimode solutions, 400 gig base SR16, the base is baseband, SR is short wavelength reach, so it's an 850 nanometer reach. 16 is the number of pairs. That was part of 802.3BS. That standard was completed at the end of last year, December 2017. And the current standard that's under development is 802.3CD, and that'll introduce 200G base SR4, so that's 4 pair, 200 gig, and then 100 gig base SR, so 100 gig over 2 pairs, and a 50 gig single pair solution, which again will be completed by the end of this year. Just as a verbal update beyond that, there's a new task force, 802.3CM, that is actively being pursued and is developing 400 gig over reduced pairs and 16 pairs. So there's an SR8, which is an 8-pair solution, and an SR4.2, which is a 4-pair solution that uses 2 wavelengths. So the 4 is the number of pairs, the .2 is the number of wavelengths. The other application driver for multimode and VCSEL links is fiber channel. And this is showing the fiber channel roadmap. The 64 gig fiber channel, actually when this was presented, was targeted for 2017. We're actually still working on it. It will be completed this year. And the parallel version of that, 256 gig fiber channel parallel, so 4x64, that work will be initiated. It was, again, targeted to be completed in 2018, but realistically it'll be 2019. And these allow 100-meter reach over OM4 and OM5. They're 850 nanometer solutions. There's already an approved project for 128 gig fiber channel, FCPI-8 for the internal terminology, and there'll be a parallel version of that also. That's actually targeted for 2020 to 2021 type completion. Fiber channel's also got a suite of products for fiber channel over Ethernet, and NVMe is the other extension that fiber channel has been doing. Historically, 90% of all fiber channel links are based on multimode and VCSELs, and we see that going. Fiber channel is not a growing market, but it's a fairly steady market, and we see a significant application for multimode and VCSELs in that application space. Switching to some of the market trends that are there, it sort of goes without saying that cloud data centers are accelerating in terms of their presence and dominating in many ways. I've got some information on this slide from Cisco's Cloud Index, Global Cloud Index data survey. This is actually the one from last year. We've got some updated material from this year. Cisco does a terrific job in terms of collecting a lot of this information. And there's often a misconception that everything is moving to actually the largest cloud data centers. So these are, if I'm naming some companies, the Amazons and Googles and Microsofts, the public cloud centers, which are excellent companies that have tremendous resources and technical resources and are providing great new solutions. But it tends to be an overstatement. Sometimes it's stated that enterprise data centers are vanishing. So this is a projection from last year that that shows in terms of data center traffic growth, enterprise data centers continue to grow. For this year, just as a verbal update, they're showing more of a slight decline, a negative 5% compounded annual growth rate. So it's a flat market to a steady market, but we certainly don't believe it's a disappearing market. And there's a 451 research set of projections there in terms of the physical space that data centers utilize. And you can see projecting out to 2020, they're still showing that the majority of data centers remain enterprise data centers when you're looking at physical size or space. Multimode and VCSELs tend to be a fairly dominant application in this space. And the other point I'll make here, which again I'll be covering in more detail for the updated presentation in October, is that a lot of these enterprise data centers, especially the largest ones, are becoming transformed into cloud computing centers. So whether they do it on premises or they do it through co-location and some hybrid structure, or even accessing the largest public clouds, the cloud growth is multifaceted in terms of what's happening, and multimode and VCSELs definitely play a role there. The other sort of trend, as I was mentioning, is some of the largest of the cloud Web 2.0 hyperscale mega data centers is a view that they're all essentially all single mode type data centers. And what you find in terms of reality is that some of these largest companies use a variety of architectures, a variety of solutions. And so things essentially that are in the public domain, you can see some of the companies like Microsoft Azure and Amazon AWS utilize parallel single mode, and it's PSM4, which is parallel single mode over 4-pair solutions. And actually Amazon has increasingly moved to a duplex single mode solution also. Facebook tended to use more of the serial single mode solution, which is a CWDM4 coarse wave division multiplexing, so 4 wavelength solution. But companies such as Google and Alibaba use parallel multimode solutions, SR4, as part of their mix. They also use, obviously, quite a bit of single mode. Baidu is another company that's similar to Alibaba and Google in using SR4 solutions at 100 gig today and looking for 400 gig solutions in SR4 multimode form in the future. And within the IEEE context, the way IEEE works is that you don't vote by country like you do in ISIC or by company like you do in TIA or Fiber Channel, but by individual experts who are affiliated and employed by certain companies. So you can't quite say the company voted for this, but an individual expert does. So an individual expert affiliated with Alibaba has requested 400 gig SR4, and that's what the group, in fact, is pursuing. And an industry expert affiliated with Google has requested a 400 gig SR8 solution, which is also the second FIRE PMD that's being pursued in Ethernet. Just in terms of other markets and drivers there, this is a very short synopsis of this. There's multiple presentations and many slide presentations on besides sort of if the largest hyperscale companies were centralizing some of the data processing, whatever information you needed, processes from computing or storage perspective would be in this centralized large cloud environment. The growth in IoT, the growth in video, streaming video, in terms of local analytics and AI, is really driving low latency applications. And things are actually moving back to closer to the edge. The computing is going back closer to the edge. So a simple example, if you have an Amazon Echo or a Google Assistant, it clearly reaches out to the cloud for some information, but it does local processing of information also. And as more of those devices multiply, which are projected to grow exponentially, the exact timing may be difficult to establish, but certainly the trends are that there will be more and more of those intelligent devices. You need local processing of that information. As that data aggregates, you need a backhaul or a backbone. And there's a variety of solutions in that regard, but certainly the value proposition of multimode and VCSELs makes a lot of sense. Another very high growth area is, in fact, co-location data centers. and some of the leading companies, as part of their mix, are using multimode and VCSEL links today. I also put in a little icon there for open fog. So between the edge and the centralized data center is an area that some people call as fog computing, essentially, which is something that Cisco uses in its terminology, and there's an alliance called open fog. The other area that's undergoing transformation, as are all areas of data processing computing, really driven by what's happening in the cloud. So some of the drivers in clouds are basically to do network function virtualization. There's all elements of virtualization that's going on, and that the networks are more software defined. So NFV and SDN are the acronyms. And central offices, especially as 5G comes on, as PON increases in data rates, as traditional telco applications are there, portions of the central office are facing the pressure of being transformed into data centers. And it's still early in some of that development. There's some forums such as CORD, which is central office re-architected as a data center, but the individual service provider companies, and this actually applies on the cable side also, are essentially re-engineering portions of their central office or their head end to provide cloud computing type data center functionality. And again, based on the reach, if you've got a short reach application, multimode and VCSELs make sense, and some companies are already deploying 40 and 100 gig multimode links in this data center transformation. From a standards ecosystem perspective, this chart is looking at some Burroughs data. This is from last year that shows OM3 and OM4. It's a North America only data. And within the chart is really when OM3 and OM4 were introduced. These are TIA dates. It's also introduced through ISO and IEC. And the applications that essentially help drive the growth of those. So there's a mutual interaction there. As the particular media type is developed to serve the applications help drive the growth of that media type in creating solutions that add value to the industry and to customers. So as we've moved from 10 gig to 40 gig to 100 gig on the Ethernet side, and from 4 gigabit fiber channel to 8 to 16, and we're introducing now 32 and 64 on fiber channel, and we're introducing 400 on the Ethernet side. We're getting growth of OM4, and OM5 was created specifically to take advantage of multi-wavelength solutions. And as those applications come online, the value proposition for OM5 grows, and we're beginning to see that in terms of the application drivers, and we're seeing deployment of OM5 from a commercialization perspective. Just touching on OM5 standardization, it's just, I won't go into the details here, but again, it's fiber, cabling, and application standards, all actually moved rapidly with pretty much unanimous industry support to create a multimode new grade of multimode fiber that extends the 850 nanometer performance of OM4 all the way out to 953 nanometer, which allows essentially the accommodation of at least 4 wavelengths. So it could be 2 or 4. It could be potentially in the future as many as 8 wavelengths on an economical grid spacing. So those standards, these are the dates essentially when things were introduced. When the presentation was put together, things were still in process. They're all now finalized, and everything is in fact fully standardized on the OM5 side. Just a comparison of some of the key parameters. If you look at the effective modal bandwidth, OM5 and OM4 at 850 are identical. So it's a drop-in replacement for OM4 at 850 nanometer. In terms of field testing, the bottom 2 rows, and ease of connectorization, again, OM5 is a drop-in substitute for OM4. What OM5 does is it basically at 853, it specifies 2470 in terms of the effective modal bandwidth. It also has lower chromatic dispersion than OM4, both at 840 and 953, and it has a specified cable attenuation. Now, since this table was put together, again, as sort of an update, a verbal update, both IEC and TIA are actively moving to characterize OM4 and OM3 at the wider wavelength range up to 953. So they're also suitable for multi-wavelength solutions. Just like with OM3 and OM4 and OM5, with each multiple wavelength solution, there's a difference in reach in terms of what's there. And there are companies out there that have OM4 plus type solutions that also fit into that mix. This is, again, a snapshot from about a year ago. There's multiple companies, essentially all the major leading companies, North America, Europe, Asia, are providing OM5 solutions. They're commercially available and are, in fact, being deployed currently. The other area, besides Ethernet applications, is multi-source agreements, or MSA. There's an SWDM4, again, short wave division multiplex and MSA, that was announced in 2017. And this was to specify 40 gigabit and 100 gigabit over one pair of multimode fiber. And at ECOC in 2017, Finisar actually demonstrated a eSWDM4, an extended reach transceiver, as a demo in terms of the capability of what's there. On the 40 and 100 gig, the standard SWDM4 parts, those parts started shipping at the end of 2017, at the beginning of 2018, so they're commercially available products today. The other one in this chart actually shows both the SWDM4 in terms of the different transceiver types, whether it's BiDi or SWDM4. BiDi is a bidirectional two-wavelength solution. The number of wavelengths that's used, the reaches for OM3, OM4, and OM5. The one, again, update that I need to add here is that there was just recently a MSA announced for 400 gig BiDi. The specs are being developed. They're expected to be released soon in third quarter of this year. But what they've already stated is their goal is to have both a 400 gig and 400 gig over 4 pairs and 100 gig BiDi as part of that MSA. And from the 400 gig side, they've indicated reaches of 70 meters for OM3, 100 meters for OM4, and 150 meters for OM5. So very similar to, it'll fit perfectly into this table in terms of what's happening with multi-wavelength solutions. In terms, switching to IEEE and the Ethernet working group, so this has been a very successful working group in developing a range of Ethernet solutions. It's a very active area that stretches into PoE and copper and automotive, but on the fiber side has had the leading Ethernet standards over multiple years at this point. There was a call for interest, which is how basically the standards process works, in November of 2017, looking at next generation 200 and 400 gig PHYs over reduced multiple mode pairs. And there was very wide support for this CFI, and what happened was a study group was formed. And actually one of the co-authors for this paper, Robert Lingo Jr., is the chair for that study group, and the study group has actually now moved to the next phase of the standards development process, which is to become a task force. So, a lot of the basis for, as the case was being built for why we need such a standard, is that if you look at 100 gig base SR4, and this is data from light counting used with their permission, of shipments of 100 gig solutions on a QSFP28 form factor. And the largest cloud companies and largest enterprise data centers started using all variants of that. So both the SR4, all four, the SR4, the PSM4, which is a parallel single mode solution, the CWDM4, which is a duplex single mode version, and the LR4, which is a longer reach type solution. But they're all being deployed, and it basically indicated the need for a 400 gig SR4 solution. I won't dwell on this particularly, and I'll explain why, but on the enterprise side, common architecture here is shown. There were actually, one of the things that happened in this IEEE forum in the study group is that a lot of end users participated quite actively, which is not necessarily common in IEEE standards, but this shows typical architecture of a spine switch with a duplex connectivity to a leaf switch, and then a breaking out on 4-pair cabling to servers. So as those server rates have gone from 10 to 25 and 50 and the associated SerDes rates, the uplink rate goes up, and so this indicates a need from going from 40 to 100 gig, but also the need for 200 and 400 gig duplex solutions. And this summarizes, again, some of the key end user, customer type input, expert affiliated, Dr. G from Alibaba, Zhuawei Shen from Google, David Peter from AMC, and some of the, we had actually 19 enterprise type industry experts from 15 different countries, from different industries and different markets, indicating the need for both 400 gig and 200 gig type solutions. In terms of technical and economic feasibility, the drivers were basically to have multiple wavelengths, and that's one of the key driving technologies, to have VCSELs operating at 50 gig PAM4, and to have parallel cabling with MPO termination. And all of these have actually established foundations that we're building on to create these new PMDs and PHYs. The Ethernet working group did agree to, the study group agreed to have an objective for 400 gig over 4 pairs and 400 gig over 8 pairs. It did not, however, the way Ethernet works is you have to get 75% of the participants to agree to a particular technical motion. An objective is a technical motion. 200 gig over 1 pair did not have that support. The slide talks about a task force will likely be formed. It was formed in May 2008, and we've had 2 meetings, May and in July since then, and the baselines for both the 400 gig 4 pair, which is 400 gig SR4.2, and the 400 gig over 8 pairs, 400 gig SR8, have been adopted. So we're moving forward to developing the draft standard and then the final standard. Draft standard, the initial one by the end of this year, and the final standard by the end of 2019 are the goals. So I guess as I get to the summary, our view is that there's still very much a bright future for OM5, OM4, and OM3 multimode fiber. As I indicated, historically, these have been the dominant, multimode VCSEL links have been the dominant short-reach links. So while maybe it's not dominant anymore, it's still a very strong market position. There's a lot of valid both single-mode and multimode solutions there. The standards ecosystem continues to essentially support multimode and single-mode. A lot of industry support there. There are new MSAs for both SWDM and for BiDi solutions. The next generation 200 and 400 gig study group has now become the 400 gig multimode task force and is developing standards in that category. OM5 is fully standardized and commercialized. OM5 builds on and reinforces on the value that OM3 and OM4 have had and provides in many ways the best future-proof value proposition and continues the future growth and relevance of multimode and VCSEL links. So with that, I'll hand it back to Ed. Thank you.
And thank you, Mabud. At this time, we will ask as many questions from the attendees as time permits, starting with this first question. Briefly, can you kindly explain the differences and benefits of MMF from single few mode fiber solutions? Are the applications different?
I'm sorry, I didn't catch the last part of that, Ed. You said MMF?
Yes, I'll reread. Can you explain the differences and benefits of MMF from single or few mode fiber solutions? Are the applications different?
So the application spaces can certainly overlap. For multimode, it's principally a short reach application, and because of, when you look at the link cost, because of the transceiver cost and connectivity costs, which are lower in multimode links, for the shorter links, it's the more cost-effective solution. But as single-mode cost structures on the transceiver side have declined with silicon photonics and other technologies, there is overlap in the application space there. But as you get to those very short reaches, and certainly the 100-meter type reaches and 300-meter reaches, multi-mode retains still a significant cost advantage and value proposition advantage.
Thank you. Next, for hyperscale data center in the future, will MMF be the dominant solution?
I guess my short answer would be no if you say dominant. It will be a significant solution, and I think that's part of what I was trying to present here. And the term hyperscale actually is a fairly diffuse term. Cisco in its cloud index data actually defines it based on revenue for the different, whether you're infrastructure as a solution, software as a solution, or platform as a solution. So they have 24 companies that they put in that category. And it's actually a wide range of companies if you look at that. Hyperscale often means mega data centers, so the ones with the longest sort of reaches, 500-meter or beyond reaches. So a portion of that segment for some of those even largest hyper data center providers will use multimode links. It's on their roadmap. They're publicly indicated that. There's others that will be more single mode and use AOC and DAC for the shorter links.
Okay, thank you. Next, are there any installation or maintenance advantages to using multimode fiber?
Yeah, so again, because of the nature of multimode with having a larger core, because of the connectivity in terms of termination, in terms of use, there are some advantages. It's somewhat of a tricky question because the basic rule when I talk to my connectivity friends is always clean and inspect before you make a connection. But in sort of more real-world settings where people don't always follow those procedures, there's a higher tolerance to contamination on multi-mode type connections than to single mode. So that does become an operational advantage.
Okay, thank you. Next, is the selection of MMF solutions a regional demand issue, or will MMF usage grow globally?
So we tend to look at both Burroughs, which looks at North America, and also CRU, which projects globally. And there are obviously differences regionally. It's not identical, but they both trend that multimode is growing, that there's more adoption from OM3 to OM4, and there's an increase in OM5 that's happening. So both those, market forecast and research organizations have similar long-term growth for the products, but there are definitely differences in North America versus China versus Europe and Asia Pacific, Africa, et cetera.
Okay, thank you. Next, as the high-performance fiber reaches distances close to 500 meters, could it be used in the 5G backhaul network in the future? This could be a cheaper solution with VCSELs?
Yeah, so part of the sort of overall looking at the telco central office type applications, 5G is putting a great deal of data into the network, and absolutely the backhaul piece of it. Exactly what that reach is and what that application is, I don't believe I have a definitive answer there. But it's certainly something that the major service providers are looking at as an option. It has the same value proposition that it's always had in the enterprise LAN and data center space.
Okay, thank you. At this point, here's another one. Do you expect adoption of the SWDM4 transceiver at large scales in the near future?
That's an interesting question. So SWDM4, as I was indicating, was introduced commercially at the end of 2017, 2018. There has been an uptake. I'm not sure that I can have a good forecast as to how successful it's going to be. It competes with BiDi solutions in that space. I think they've both had traction, but I don't think I am in a position to forecast how well SWDF4 will do relative to BiDi or vice versa.
Okay, thank you, Mabud. At this point, I have no more questions coming in, so I wanted to thank you, Mabud, for presenting this very interesting and important topic today. Please note the contact points being shown should you wish to contact Mabud after today's event. Each of these IWCS webinar series presentation events are recorded and will be archived on the IWCS.org website. It normally takes up to 2 weeks for these to be posted. The IWCS webinar series will conduct presentation events on a monthly basis. Webinar events will take place on the third Friday of each month at 10:30 a.m. Eastern USA time. Our next scheduled webinar event will be on Friday, October 19th at 10:30 a.m. Eastern USA time. Each of you will be receiving an announcement for the event a few weeks prior. Please feel free to share our announcements with your colleagues so they can join in and register. For over 66 years, the IWCS International Cable and Connectivity Symposium has been a recognized leader showcasing new technologies in cable and connectivity products, processes, and applications. Our next annual international conference will take place on Sunday, October 14th through Wednesday, October 17th, 2018 at the Rhode Island Convention Center in Providence, Rhode Island, USA. In addition, the third annual UL and IWCS China Cable and Connectivity Symposium will take place on Monday, March 25th through Wednesday, March 27th, 2019 at the Marriott Hotel City Center in Shanghai, China. Please visit our website at IWCS.org for more event details. In just a moment, you will see a brief survey so that you can provide us your feedback and comments on today's event so that we can further improve this webinar series for you. Thank you for participating, and this concludes today's event.